Hello everyone, we are group number 16 working on design and implementation of forward collision warning system at KPIT Apex Lab Pune. This is the forward collision warning system model which is derived from an algorithm mentioned in the research paper titled as forward collision warning system considering both the time to collision and safety braking distance. This research paper suggests uh, obtaining the warning level based on some parameters. Firstly, it calculates three distances dB, dP, and dr, which are further used to calculate ds max and ds min, which are the upper threshold and lower threshold values of safe distances. This is the suggested algorithm by the paper. These are the subcharts of rule 1 and rule 2. Basically, it takes the inputs as ds min, ds max, time to collision, then dd by dt, which is the relative change in the velocity, then the distance, relative distance d, and tc, which is threshold time, which will be considering while equating it with time to collision ttc. The dataset which was used for validating is as follows. The inputs are v, d, and theta s, which corresponds to velocity of the host vehicle, the relative distance between them, and the angle of the road. To give a brief information about the model, this is the model, and the distances are dp, dr, and db. Uh, which further consist of smaller subsystems using simple gain blocks. dr is calculated using this subsystem. We have implemented a MATLAB function which was just taken to get the average reaction time based on the age. It is based on statistical data also included in the research paper. While dB is calculated using this MATLAB function, which corresponds to the formula stated here. The parameters and their meanings are included in the research paper as well. Moving forward to the converted subsystem, it converts the distance d with dd by dt, which is the relative velocity between two vehicles, and ttc, which is time to collision. Further, we have our logic algorithm, which is implemented in state flow, which is very identical to the algorithm implemented in the research paper. Rule 1 consists of warning levels 1, 2, and 3, and rule 2 consists of warning levels 0, 1, and 2. To give a brief information about the warning levels, there are four warning levels as 0, 1, 2, and 3, whereas 0 is a mild warning level. It can be interpreted as just an attention, while the warning level 3 is to be interpreted as severe, and it is imperative that the driver should use the brakes immediately. Let us run this Simulink model. So currently what we are doing is we are performing MIL testing, which is model in loop testing. Here we run the model just in the Simulink in the simulated environment. So this is the expected output. We also performed SIL, which is software in loop, where we perform code generation and compare the result with MIL. So the results of SIL are included in the report, while we also performed PIL, which is processor in loop. Here we take the generated core code and flash it into the STM32 microcontroller and evaluate the output of the hardware with MIL. And we tested the PIL where all the signals matched. For SIL and PIL testing, we used the Simulink app called SIL/PIL Manager. Uh, All the results of this test are also included in our project report. Thank you.